Hello everyone, this is Reza Vaezi and this short recording is about correlation. So what is correlation? It is a statistical measure that tells you how strong the relationship between two attributes or two variables are in your dataset. It ranges between -1 to +1. Correlation coefficient measures the strength of a relationship by looking at how closely the data falls along a straight line. If it falls perfectly along the straight line in a positive direction or in an upward slope, then it is going to be +1. If it is perfectly falls along a line with a downward slope, then it is going to be -1. So positive correlations are between 0 and 1 and negative correlations are between 0 and -1. The closer to 1, the stronger the relationship. Here's an example that explains positive versus negative correlations. For example, there is a positive relationship between heating oil usage and insulation rating. As you can see, when heating oil rises, then the insulation rating rises as well. And when the heating oil declines or falls, the insulation ratings also fall. This is an example of positive relationship. It means that both variables or both attributes are moving in the same direction. When one increases, the other one also increases. Negative correlation means that the variables under study are moving in opposite directions. It means that when one goes up, the other comes down. Here's an example. Temperature rises, but the insulation rating falls. Or the temperature falls, but the insulation rating goes up. Here's a graphic that helps you understand the correlation strengths better. As you can see, between 0 and 0.4, the absolute value, there is no correlation. So any readings between 0 and 0.4, whether it's positive 0.4 or negative 0.4, means that there is no correlation. Between 0.4 and 0.6, it indicates some correlation. Between 0.6 and 0.8, we have a strong correlation. And anything between 0.8 and 1, it indicates very strong correlation. However, you should be aware that very strong correlations usually tell you something. You should know that when you see a correlation above 0.85, you have to investigate. You have to investigate the two variables that are included in the analysis. High correlations above 0.85 and 0.9 are not usually good, and they can be troublesome or they can cause trouble in analysis methodologies that they highly rely on correlation, or they highly rely on the independence of the variables. Basically, high correlations or strong correlations indicate that your variables are not independent. One thing that you should consider and always remember is that the correlation tells you about the extent and direction of a relationship between two variables. It does not tell you anything about why the relationship exists. In other words, it does not indicate causation. It just tells you that a relationship exists. But why it exists, it does not tell you anything about it. You cannot also use correlation to support any sort of causation. You cannot have a theory that X will cause Y and then use the correlation between X and Y to support your variable. That's wrong. That is not what the correlation use is intended for. You should also remember that correlation coefficients are not indicators of shared variability. They are not percentages as well. So you cannot interpret the correlation coefficient of 0.8 or 0.7 as 80 or 70%. You cannot say that when two variables have correlation of 0.8, they share 80% variance. The correlation coefficient does not tell you anything about shared variance. However, it tells you something. If you square it, then the R2 or correlation squared indicates the percentage of variation in one variable that is explained by the other variable. So remember, the mathematical process in correlation is only aimed at telling us about the strengths and direction of the relationship among attributes, nothing about causation and nothing about shared variance by itself. To make this more clear that the correlation does not indicate causation, let me give you some examples. For example, not keeping money in a savings account is a common behavior of many CD holders, just as being male is a common feature of beer drinkers. Beer companies seek out males to market their products, so should banks seek out people with no money in savings in order to sell them certificates of deposit? Probably not. You can assume that CD holders have no money in their saving accounts because they use that money to buy CDs. A more common reason for not having money in a saving account is not having any money. And people with no money are not likely to purchase certificates of deposit. So as you can see, not having any money in your saving account and having CDs are highly correlated. But you can't use it as causation that, okay, those who don't have money in their savings are very highly or are very likely to buy CDs. So whenever that you look at correlation, you cannot use it as causation. You might have some extra evidence, the evidence that not relate to the correlation coefficient to support your theory that X leads to Y or X cause Y. But merely using correlation readings, you cannot use it for causation support.